The first step is digital waste bank. It is about building an online platform combined with offline sites, serve as a transfer hub to encourage households to reduce glass and plastic waste at source. The second step is to send a car to collect the garbage. The third step is when the garbage is full, the data will be updated to a cloud and the garbage truck will come and send the organic waste to compost and all other garbage is sent to the smart garbage collection station. The fourth step is garbage trucks from each area will be transported to the nearest smart waste system. And the fifth step is organic waste is sent for composting and the processed fertilizer will be made into fertilizer and fermented into biogas. The sixth step is the waste station is powered entirely by clean energy to operate. The seventh step is the waste is further sorted by robotic arm and AI recognizing system. Finally, these plants receive hard-to-treat waste and treated waste for recycling and disposal. Indonesia is the second largest waste production country in the world. In Bali, each day one person produces much solid waste in average, plastic and glass waste in particular, so it is urgent to make some strategies to intervene in local behavior change. So, the main strategy is called digital waste bank. For example, some refill station will be set in each of your community. Local producers provide their refill contents at the station. Refill type includes products for cleaning, personal care, snacks, kitchen oil. People can bring their reusable containers and get their bottle refilled in digital waste bank easily. So as it shows, Digital Waste Bank project built an online platform combined with offline sites. The original waste bank offline remains function. They buy and dispose of waste collected from communities and streets, but with the support of digital platform. People could scan a code online, accumulate their credit and exchange for money. It shortened your queue time and helped you collect waste change into your income. Then some reverse vending machines will be set along community streets, in front of shops within 20 minutes life cycle. With different brands and machines, all the waste collected could be sent back to producers. Then they can complete their waste life cycle. Decentralized waste recycling facility product specializes in the treatment and recycling of organic waste using organic waste residues. The facility manufactures a high-quality fertilizer, the alternative to chemical or pest-based fertilizers. So not only it is good for the growing of crops, but it is also for the environment, helping to create a greener ecosystems. Organic waste, including food waste, is located by being arrows from households in Bali Island and taken into nearest recycling facility. Materials are tipped in the waste reception area and visually checked to ensure that they are all organic in nature, and non-organic materials are quickly removed and sent to MYT for disposal. Large blowers force air into the organic waste piles, which are watered, mixed, and loosened up to maintain optimistic conditions. Active aerobic microorganisms produce heat during the decomposition process. The temperature reaches over 70 degrees centigrade, which centralizes the compost, that is, makes it free of weed seed, insect eggs, and larvae or pathogens like E. coli. Once stabilized, the material is skinned and cleaned to produce the final compost. Compost is then delivered to farmers for use as a fertilizer and soil conditioners or back for sale in garden centers. Allow this natural cycle to begin again. Because of undeveloped traffic in Bali and the presence of many motorcycles, the traffic in the Denpasar area is congested all year round, which generates additional carbon emissions. I chose to use a smart approach to solve these problems. Each smart bin has a sensor inside to detect if the bin is full or not. Then the garbage truck is able to know the most energy-efficient route by using data from cloud computing and navigation. At a certain time, the cart will depart to collect the garbage based on the navigation. If the bins are not filled, the garbage truck will ignore them and choose to go to those that are full. Traditional garbage cans also face the situation of not having enough capacity. The smart garbage cans can not only monitor the data of the garbage cans, but also compress the garbage, making the garbage cans hold more garbage, 8 times more than the traditional garbage cans. The sensor can modify not only the amount of garbage, but also the type of garbage. Finally, multiple data are updated to the cloud for calculation to get the best route and the best collection time. The end result is a system of intelligent waste recycling management, which can reduce the carbon emissions generated by transportation by 60%. The waste will be returned to the waste station by a garbage truck, which is responsible not only for transporting the waste, but also for recycling and reusing it. By 2045, the energy consumed by the operation of waste station will be completely replaced by clean energy, including the transportation and disposal of waste. In addition, robot arm and intelligent AI recognition system will further sort the waste. Different types of waste will be treated in different ways. Waste that is extremely difficult to handle will be sent to other plants, such as the MYT plant.
Maximum yield technology, MYT for short, uses waste as a resource to extract the maximum energy potential and raw material from residual household waste. High-quality raw materials and energy sources are generated from over 100,000 tons of waste each year, including biogas, fuels, metals, clean water, and minerals. Step 1. Waste intake. The waste begins its journey through the MYT facility. The grabber loads waste to conveyor belts. Large impurities and recyclable waste are sorted out. Step 2. Mechanical processing. Here, the waste is automatically separated according to the material type and differences in size. The systems guarantee safe operation and a systematic separation of fuels, minerals, metals, and a small amount of non-recyclable waste. The checked-in waste then proceeds to the third step of the process. Step 3. Biological stage, including 2 minor steps: water treatment and exhaust air treatment. After being in the mixer for a short period of time, presses are used to separate water from solids. In the process, more electricity and heat are produced. In the end, purified water for agriculture irrigation purposes, and nutrient-rich liquid fertilizer are all available. Step 4. Biological drying. The biological drying to take place is both energy-saving and economic. In tight-sealed concrete tunnels, air passes steadily through the waste, providing the microorganisms with oxygen. These microorganisms feed on the material organic components and produce heat energy for drying. After a brief treatment, the homogeneous dry and fine solid waste is available, which can be easily broken down. Step 5. Mechanical material separation. Economically utilizable raw materials and high-quality energy sources have been obtained from waste material in industrial processes, which can be used to replace fossil fuels like coal and crude oil.